Hi, we're looking at integer exponents today, but first I want you to recall, for instance, if I raise 2 to the 5, what does the 5 tell me to do to 2? Meaning what? I have to multiply 2 by itself, 1, 2, 3, 4, 5 times, which gives us 32. And this is what we did, I think, a couple of sessions before. Now, what if I have 2 to the third, and then I'm multiplying it by 2 to the fifth. And what do I get as a result? Mind you, 2 to the third is telling me I'm multiplying it 3 times, okay, the number 2. And then this one is how many times? 5 times. 1, 2, 3, 4, 5. There are how many 2's there are? 1, 2, 3, 4, 5, 6, 7, 8. In other words, if I'm multiplying the same base, but with different exponents, 2 to the third, 2 to the 5, as long as the base is the same, then I can go ahead and add the exponents, which is 2 to the 8. This is what we call as the product rule. Okay, the product rule in integer exponents. So, in other words, if I have a, let me use a different one. If I'm raising a to the nth power, and I'm raising a again to the nth power, what I'm doing is I'm adding the exponents n plus n. Okay? This is one way of dealing with exponents. So, if I have 3 to the 4th times 3 to the 7th, all I need to go ahead and do what? 3 to the 4 plus 7, which is 3 to the 11th. 2 to the third times 3 to the second. We cannot use the product rule because the bases are different. So you have to do 2 to the third, and then whatever you get, 8 and 3 to the third times 9, which is 72. So this is not 2 to the third plus 2. So make sure before you do the product rule that the bases are the same. And another concept that we talked about is, let's look at this one. So if I have anything to the power of 0 is 1. A to the power of 0 is 1. That's one rule of integer exponents. So if I have 6 to the 0, it is 1. If I have negative 6 to the 0, mind you, I am raising not just only 6, but also the negative number. There is always 1 embedded in it. It's still 1. But if I have negative 6 to the 0, this one tells me first raise 6 to the power of 0, which is 1, then bring the negative 1. So, if there is no parenthesis that covers the negative and the 6, what this one is telling me is first raise 6 to the power of 0, which is 1, and make sure to put a negative sign next to it. Okay? Okay. Now, we say 3 to the second is 3 times 3, which is 9. But 3 to the negative 2, the negative sign tells me what I should do to the base. Meaning what? I need to turn negative 2 into positive 2. In order to do that, I have to find the reciprocal of 3, which is 1 over 3. So this is 1 over 3 to the second, which is 1 over 3 times 1 over 3, which is 1 over 9. Okay. In other words, if I raise a to the negative n, I have to change negative n to the positive n, and in order to do that, I have to find the reciprocal of a, which is 1 over a to the n. Okay? So, if you have 5z to the negative 3, then what you need to do is what? Find the reciprocal of 5z, which is 1 over 5z to the third. This means then we can distribute that. 1 over 5 to the third times 1 over z to the third. You can find 5 to the third, which is 1 over 125 z to the third. Okay, so that takes care of the negative exponents, and probably we should do, we forgot something else. Now conversely, suppose I have 3 to the negative 2, I said it is 1 over 3 to the second. Okay. But conversely, what happens if I do 1 over 3 to the negative 2? 1 over 3 to the negative 2 means what is the reciprocal of 1 over 3, which is 3 over 1. So it is 3 over 1 to the second, or 3 to the second. So in other words, if you have 1 over a to the negative n means a to the n. In order to turn the negative n to the positive n, always find the reciprocal of the base. Okay. So that is what the integer exponents is. Okay. Now, you remember when we did 2 to the second, probably let's do this, 2 to the fifth times 2 to the third, multiplying the base. Then we did what? We added the exponents, so this would be 2 to the fifth plus 3, which is 2 to the eighth. Okay. Now, this is what we call the product. Let's do the quotient rule. What happens if I divide 2 to the fifth by 2 to the third? 2 to the fifth is 32. 2 to the third is 8. And 32 divided by 8 is 4. Right? But if I use the quotient rule, if the product rule tells me to add the exponents, the quotient rule tells me to subtract the exponents. So meaning what? I'm subtracting 3 from 5, which is 2 to the fifth minus 3, which is 2 to the second, and which gives us 4. Okay, so this is what we mean by the quotient rule. Okay. So let's do some examples of that. So in other words, if I have a to the n divided by a to the n is the same as saying a to the n minus n. Again, the rule applies as long as you are dividing the same base. Okay. All right. So let's do just some exercises on this. suppose I have k to the 7th over k to the 12th. Again, making sure that we have the same base. Then go ahead and use the quotient rule, k to the 7 minus 12, and this is k to the negative 5, right? But don't leave your answer as a negative exponent. You have to change it into positive. Then you know the reciprocal would be 1 over k and 1 over k to the 5. Okay? Probably. Okay. So if I have 8 to the negative 2 over 8 to the 5th. Okay? Again, make sure the base is the same. So this would give us 8 to the negative 2 minus 5, which is 8 to the negative 7. Now go ahead and change the negative 7 into positive 7, meaning what? 1 over 8 to the 7, and go that way down. One more example. Suppose you have z to the negative 5 over z to the negative 8. And this is the same as saying z to the negative 5 minus negative 8, okay, because you're subtracting one from the other. And that would give us z to the negative 5 plus 8. And then you go ahead and solve this, so you end up with z to the 3rd. Okay? So this takes care of the quotient rule. Okay? Now, let's look at three to the 4th power, and that 4th power is raised to the 2nd power. So suppose let's look at this one as just the base, something raised to the 2nd power. What does that mean? This means 3 to the 4th times 3 to the 4th. Okay, 3 to the 4th is raised to the 2nd power. Now, because the base is the same, then we can add the exponents, which is 3 to the 8th, using the product rule. But we don't have to use the product rule. If I raise 3 to the 4 and 3 to the 4 is raised to the 2nd, it's much easier to multiply 4 by 2. So 3 to the 4th to the 2nd multiplied, and you get 3 to the 8th. This is what we call as the power rule. If an exponent is raised to another exponent, use the power rule. Meaning what? In other words, if you have a to the m, and that is raised to the nth power, all you need to do is multiply a to the m times n, and that is what we call the power rule. Okay? So let's do some examples of these. Suppose you have this is the same as saying 3 to the 4th, y to the 4th, right? And 3 to the 4th is, if you do your calculation, it becomes 81 y to the 4th, and then we're done. Now, how about 6p to the 7 to the 2nd? Mind you, the exponent 2 is distributed to 6 and p to the 7. So this is, you can write this as 6 to the 2nd times p to the 7 to the 2nd. But 6 to the 2nd is what? 36. Then use the power rule. 7 times 2 is 14. So this is p to the 14th, and then we're done. let me do a couple more exercises on negative exponents. And we might suppose now I have 1 over 2 to the negative 4. What would you do? This is the same as saying 1 to the negative 4 and 2 to the negative 4. Or you can say what? 2 over 1 to the power of 4, right? And that will give us 60. So I think, let me do a couple more exercises before we end this session, so that you can have, probably give you an example of each. Exponents. X, oops. So x to the negative 4 y to the second over x to the second y to the negative 5. So you have to use all the rules that we discussed so far. Okay. So do them piecemeal wise. First, try to solve this. X to the negative 4 over x to the second reminds us of the quotient rule. So I'm going to do x to the negative 4 minus 2. And the same also goes to y. So this is y to the second minus negative 5. This will give us negative 4 minus 2 gives us x to the negative 6. Y to the 2 minus negative 5 gives us y to the 7. Again, we cannot leave negative exponent as an answer, so you have to write y to the 7 stays where it is, but x to the negative 6 comes down, which makes this y to the 7 x to the 6. Okay. Let me do a couple more. Probably something that could be a little bit challenging. So let's say 2 to the third x to the negative 2 to the negative 2. Okay. Mind you, you could use sometimes you could use power rule, product rule, or quotient rule. You can have choices, okay, but it's depending upon the question. So I can go ahead and use a power rule. So meaning what? Everything is raised to the negative 2 power. So I could rewrite this as 2 to the third to the negative 2 and x to the negative 2 to the negative 2. Now 3 times negative 2 gives us 2 to the negative 6. X to the negative 2, negative 2. Negative 2 times negative 2 gives us x to the 4. And then you have x to the 4th over 2 to the 6th, right? Then go ahead, you have a calculator. Go ahead and 2 to the 6th would give us 64. Okay. Let me do one more challenging problem. This one will take us a little more time, but I find it necessary because it holds all the rules that we have discussed. So let's do this. You have 3x squared over y to the second, and then you have 4x to the third over y to the negative 2 to the negative 1. Now, again, let's look at piecemeal wise. Let's try to simplify this. Everything is raised to the second power, so I can use the power rule. So go ahead, 3 to the second is 9. X to the second is 2 times 2 is 4, so you have 9x to the fourth. Over what? Over y to the second. Let me put a parenthesis in here. Do the same thing in this one. This one, since everything is raised to the negative 1, what if I change everything, meaning what? Find the reciprocal of 4x to the third over y to the negative 2. Okay? So in that case, don't touch this negative sign. Don't change it because you are raising everything to the negative 1. And this becomes 4x cubed to the y. So in that way, I got rid of the negative exponent here by just switching the order. Okay. So now I have what? Let me rewrite it without the parentheses. 9x to the fourth, y to the negative 2 over, let me do 4x to the third, y to the second. I'm just rearranging it. Mind you, 9 over 4 are prime, you can't simplify them, so just write 9 over 4. X to the fourth over x to the third, we can use now the quotient rule. So 4 minus 3 would give us x to the 1 or just x. Y to the negative 2 over y to the second. So we are subtracting 2 from negative 2, so you end up with y to the negative 4. Because negative 2 minus 2. Now, we don't want a negative exponent as our final answer, so we can rewrite this as 9 over 4. The x stays on top, but the y comes down, and voila, we're done. Okay? So that takes care of the exponents.